So I'll start with, this is just sort of our one slide elevator pitch overview of what AMReX does. So AMReX is a software framework for building massively parallel, block-structured, adaptive mesh refinement applications. So in the picture there is an example of a simple adaptive mesh refinement application. This is solving the advection equation for a ball of dye that's is moving in a prescribed velocity field. And we're solving that kind of PD on a mesh that looks like that. So the white boxes are the coarse level, the gray boxes are the next finer level, and the black boxes are the finest level. And the structure of this mesh deforms to track the dye as it moves. And we also have some particles that have been added to trace the velocity field in this example. So yeah, we're kind of in the math library side of HPSF. AMReX is written in C++. We currently have a minimum standard of C++ 17, although some of the applications have already bumped to C++ 20. And we also have optional Fortran and Python bindings. So the Python bindings are especially interesting because they can be used to couple AMReX simulations into workflows that do like AI or machine learning, or couple two codes together. And AMReX was developed as part of ECP, and we're now trying to kind of steer its development in this post-ECP world. So we support cell, node, face, and edge-centered meshes, and also particle data. AMReX handles things like parallel communication, domain decomposition, and load balancing under the hood. So the boxes in this image can be assigned to different MPI ranks and GPUs. And there's tools for doing that in an even way. There's tools for doing the kind of multi-level synchronization operations you need to do when you do mesh refinement. So tagging cells for refinement, storing data on coarse fine boundaries, regridding. We have support for complex geometry via a cut cell approach to embedded boundaries. We have a number of native geometric multigrid solvers that operate on a hierarchical mesh like that. And we also have interfaces to packages like PETSI and Hyper as well. And finally, we support all the different major GPU and CPU architectures that are big in HPC right now. This slide is showing kind of just a sampling of different application codes that use AMReX. So people have used our package to solve a wide variety of different types of equations and different problems. Astrophysics, cosmology, accelerator modeling. Some of these I think are interesting because they don't fit in with the kind of paradigm that you traditionally associate with adaptive mesh refinement. So we have projects applying or using AMReX to study epidemiology, or the growth of biological cell modeling, or the growth of fungi in like an agar type surface. Another point to make about this, I guess, is a lot of these projects were also ECP applications, but many of them weren't, and there's like a growing community of users that are kind of just finding us on GitHub and using us to help solve their science problems, which is great. In terms of why we were interested in joining the High Performance Software Foundation, I think the short answer is there's just a lot of overlap between our goals and our philosophy and that of HPSF. AMReX has been open source since its inception in 2017, and we've always been kind of driven by the development of AMReX has always been driven by the needs of our user community. There's also an interest in performance portability, so we want our framework to be able to work on all kinds of architectures ranging from laptops to all the different major supercomputing centers. When I checked this morning, we had about 181 contributors, like unique contributors on GitHub. 10 of those members are part of our technical committee, which means they have the authority to merge pull requests. That number grows to 15 if you count people that can contribute to the Python bindings. And it's hard to get a gauge of exactly how many users we have, but there's a JOS paper about AMReX, so in the Journal of Open Source Software, that we ask people to cite if they use AMReX in a publication, and that paper has over 450 cites to it, so maybe some users are citing us multiple times and maybe some people aren't, but I think that gives a rough idea of the user community out there. And these users are spread across different government labs, at universities, and in private industry. And they include both domestic and international collaborators. So one of the reasons we wanted to join is just increase the visibility and adoption of our framework. We always want to grow our user community, and I think especially being part of the Linux Foundation makes it easier for international collaborators to count that we'll still be around in the future. And we also are particularly interested in growing this community of contributors and especially developers, people who can push changes to the code. We also think that being part of HPSF will help improve the long-term sustainability of AMReX and help us to sort of interact with people in the broader HPC community. So this is the current members of. We have both a technical and a steering committee. So the steering committee is John Bell, Ann Almgren, myself, and Wei-Chin Zhang. And then we also have a technical committee. So these are all the people who. So the steering committee sort of corresponds to people who have admin access to the GitHub repo. The technical committee is people who have the ability to merge pull requests. And you can see that while there's a few different organizations represented there, a lot of us are from Lawrence Berkeley, and that is the thing that we would like to improve. Basically, we'd like to increase the diversity of the institutions among this group of people to reflect both our user base and the broader HPC community. And I think this is one of the things that's kind of like we joined HPSF as an established rather than a core project, and I think this is one of the main requirements that we're not meeting right now, is most of us are from LBNL. So far during HPSF, when we joined, we kind of, with the help of the Linux Foundation, we codified our development practices into like a formal governance structure. So we wrote down the process by which changes are made and how how disputes would be settled, and we haven't had to settle any disputes so far, but there is a document where that's all written down. And a big part of what we've done is we've planned this AMReX community breakout session, which is taking place all day on Wednesday in the Mississippi 1 and 2 rooms. And yeah, basically the point is just to hear about what different people, different AMReX users have been up to post-ECP with their applications. So there's a total of 17 talks covering topics like advanced load balancing, using AMReX through Python for code coupling, and AI or machine learning workflows, as well as a whole bunch of application areas ranging from astrophysics and cosmology to combustion, renewable energy, spintronics, epidemiology, and more. And also, I guess, a very tangible thing that we've gotten out of HPSF is the Linux Foundation's creative team designed a new logo for us. And I think they said we were the first project to have actually completely gone through this. So there it is. I think it's pretty cool. It kind of recalls both an adaptive set of grids and particles, as well as emphasizing the mathematical nature of our package. So we're happy about that, and we're in the process of going through a website redesign as well. So our goals for the future, we want to, improve our CI, basically. So our current system is based on a mix of GitHub actions that run every time there's a pull request, and this tests compilation on a whole bunch of different setups, and also runs a small, fast set of correctness tests on CPUs. And then we also have, kind of a homegrown solution using our own servers for testing on NVIDIA GPUs that runs a longer set of tests, and this runs every night. And another thing I guess we've gotten out of being an HPSF is we were given a free GitHub Enterprise account, which bumped the number of, runners we could have. But I guess we're interested in taking advantage or learning from, other members of the HPSF community who maybe have more experience in CI than we do, to learn how they've, set this up. And we also would like to be able to test our codes on a broader range of hardware, including, post-ECP hardware like H100s and MI300s. We're also interested in the benchmarking working group. That's another thing that we've tried to do kind of a homespun solution to, but we'd like to learn what other people are doing. And we're also interested in interoperability. I know Damien mentioned this morning, but I know that AMReX applications have used, our data structures with Cocos. I know people who have used AMReX data structures with Trillenius solvers, and we're very interested in making that easier to do. So yeah, that's all I wanted to say. I'm happy to take questions. These QR codes, one of them goes to our website and links to our GitHub and documentation and all that, and the other one is to a NERSC performance portability training series tutorial that we did that includes recorded, recorded versions of us going through the slides and the live examples. So thank you.
Hey, I'm Christy. So out of just pure curiosity, when you got the new logo, was that like an iterative process? Did they like tell you this is your logo, or the redesign, or if you're like opinionated about some of that?
So it was an iterative process. I don't think they will do an infinite number of redesigns, but they did. For example, I think they gave us 3 broad directions to pick from. And then I think we took one of them and said, we also want you to add something that looks kind of like particles to it. So they did that. And then they came back with these 3 different, colorways for it.
Any other question?
I have to add that one of the questions before we fill out was, how would you describe your project to a small child? And we punted on that. So we can't. So we actually gave them a previous logo. Sorry, all right. We gave them a previous logo and said, this is what we like about it, this is what we don't like about it. And we weren't able to describe it to a small child.
Thank you. Yeah.
So on one of the slides, you talked about wanting, one of your reasons for wanting to get involved in HPSF was increased visibility and increased collaboration, visibility and adoption. Yeah, exactly, that one. What specifically could HPSF do for you? And I'd like this to just be a placeholder for maybe other people who are speaking this afternoon to think of the same question. What specifically could we do to increase that visibility beyond just sort of passively, you joined HPSF, you're on a different set of web pages, there's more conversation about you. What proactive things could HPSF do? And I'm asking that as someone who's on the governing board.
Well, I think our hope is that as HPSF grows, it will become, at events like this in the future, maybe where there's 100 projects at it, it would be a venue where, people could learn about our framework, we could learn about other frameworks. I think that's maybe what we had in mind. Yeah, I also think that just being tied to the Linux Foundation rather than a specific national lab or even just like the Department of Energy makes it easier for international collaborators to say like, yes, we'll buy into using that.
Thanks again, Andrew.